Okay, we've kind of learned about how to solve greatest common factors and least common multiples, but those are without word problems. So today I have a couple different word problems, and we have to figure out if which strategy we're gonna use on it. So this problem says a grocery store has 16 oranges, 20 apples, and 24 pears. They need to put an equal number of apples, oranges, and pears into each basket. What is the greatest number of baskets that can be made so that no fruit is left over? One of the key things I do is to tell people to go through and find keywords like greatest number and equal number, which means we're taking what we already have and putting that into groups. We can't just make more oranges or make more apples. So in this case, we have to use our greatest common factor strategy to find the greatest factor that goes into both 16, 20, and 24. The greatest factor that goes into all three of those would be 4, so our answer here would be 4 baskets. Here's another problem. Mrs. Ford gives a science journal every 2 days, and Mr. Adams gives a journal every 7 days. They both give one today. How many days until they both give a journal on the same day again? Because we're going to be fast forwarding the future into more days, that's kind of like skip counting by days. So if Mrs. Ford gave one today, in 2 more days, she's going to give another one. So that's like a total of 4 days. In 2 more days after that, she'll give another one. That's like 6. So what we're doing is finding multiples of 2. We're going to do the same thing with Mr. Adams, but start at 7 and then count 7 more for his next journal. When you do that, you're looking for the first number they have in common. And the first number they have in common is 14. So it'll be 14 days. Here's another one. See if you can solve this. Hopefully you found that it said put an equal amount of each item into the bags. What is the greatest number that you would be finding the greatest common factor of 48 and 36?